Welcome to this second part of the video titled Performance Levels and Acceptance Criteria for Structures and Non-Structural Elements. Now, the performance levels we are talking about are of two types, one pertaining to structure and another pertaining to non-structural elements. So, structural performance level and non-structural performance levels. So, we will study this in detail. There are some designations given, some names given for structural performance levels and some names given to non-structural performance levels. And in any structure, especially in building structure, there will be structural elements and there will be non-structural elements. So, combining the performance of these two together will give the final building performance level that we shall take up in the next slides. So, the structural performance levels are like this. S1, S standing for structure, and one is the serial number 1, corresponds to the nomenclature immediate occupancy performance level. S1 is immediate occupancy performance level for structure. S3 is structural life safety performance level that we have studied in the previous slide, and S5 is the collapse prevention performance level. So, what happened to S2 and S4 in between? Those are the ranges. So, you have the S2 damage control range and S4 limited safety range. So, in this slide what we have seen, that structural performance level have been quantified and given as designation ranging from S1 to S5. These are termed as immediate occupancy performance level, damage control range, life safety performance level, limited safety range, and collapse prevention performance level. Now, certain building can be there where you have not considered at all about the structural safety. Say in a non-engineered building, there is no question of particular safety to the structure. So, that has also to be given a nomenclature, and that is given as S6, not considered. That is, structural performance level is not considered in the design. It is given a place because some buildings can be such that the structural safety was not considered. Now, let us take the non-structural performance levels. They are also given through some nomenclature and designations. Non-structural, so we start with N, and the different the states are given A, B, C, D, etc. So, NA is the non-structural performance level A, or first one, which is called operational performance level. What does it mean? It means the equipment will continue to have its operational functions post-earthquake scenario. That is, they do not get damaged and they do not lose their functions, so they remain operational. A little lower performance level for non-structural is the NB. It is immediate occupancy performance level. This is also very high and you can use it in some buildings. Then you have NC, life safety performance level, non-structural. ND is called hazard reduced performance level. So, remember NA, NB, NC and ND, these are the different levels: operational, immediate occupancy, life safety and hazard reduced performance level for non-structural elements. But in some buildings, the non-structural performance level might not have been considered at all. So, that also should be given a nomenclature, and it is given as NE, not considered. Now, we want to give nomenclature to the building performance level. As I said, building performance level is a combination of structural performance level and non-structural performance level combined suitably, not arbitrarily combined, anything combined to anything, not like that. Suitable combination is to be there. What are the suitability? We will just see it. So, topmost building performance level is the operational level, OL, operational level. So, it is a combination of S1 and NA. S1 structural performance level, NA non-structural performance level, and in short written as 1A. So, this is the highest. So, where you will use this building? It may be used in hospitals, it can be used in say nuclear power plants, it can be used in a building which contains hazardous materials whose failure will be a huge consequence to the surroundings. So those buildings require the highest stringent performance, and this is the operational level combination S1 NA. Then you can have the IO performance level for building. So it is a combination of IO for the structure and immediate occupancy for the non-structural performance level. We have seen it, NB is immediate occupancy. So S1 NB, or in short 1B. So 1B is immediate occupancy building. Its performance also very good, and I'll be happy if I have a building like this. LS is the life safety building. It is a combination of S3 structural and NC non-structural, in short 3C. So most of the buildings that we live in may be of life safety category if you analyze. Then you have the CP collapse prevention building, which is the combination of S5 collapse prevention structural performance level and NE. What is NE, you remember? Not considered category. So when structural performance is so poor, collapse prevention, there is no question of giving any importance to the non-structural performance, so it is not considered. In short, it is 5E. So these are the basic building performance levels for which you can design the buildings. So this you have to remember which is the highest performance level. Well is the highest 1A, lower, still lower is the IO 1B, still lower is LS 3C, and lowest is the collapse prevention building 5E. So what happens to the buildings now? The damage is very light in the OL building. Backup utility services continue. That is why it is operational. In 1B, minor repair may be required. Safe to occupy. You can occupy and then make the repair. So that's why it is called immediate occupancy. Immediately you can occupy the building. LS's damage does not threaten the life safety. Limited non-structural damage. CP collapse prevention damage is substantial. Building does not collapse, but you cannot repair it. It will go beyond economical repair. So you have to dismantle the building after the earthquake. However, if it does not collapse, then perhaps the life will not be lost to a large extent. That's why you want CP building preventing the collapse of the building. Here we have taken a matrix, a tabular matrix. We have given all the structural performance level from S1 to S6 in the row wise, and non-structural performance level we have taken column wise here, NA, NB, NC, ND and NE. So any cell here is the combination of the corresponding structural performance level and non-structural performance level. As we have discussed, 1A combining S1 and NA is the operational level building, which is shown here. This is the highest building possible. And next is the 1B immediate occupancy combination of S1 and NB, non-structural. Then comes the life safety, which is the combination we have seen. It is 3C, and the collapse prevention building is 5E. Some of the combinations are not viable, which are shown here by red cross marks. For example, let us take this one. Structural performance level S3 and non-structural NA is not recommended. NR means not recommended. Why not recommended? Because your non-structural performance level is highest, whereas structural performance level is much lower. So what is the use of giving the importance to the structural performance level and making cost of the things? So this is not recommended. Similarly, with high performance level or non-structural, the low performance level structural components will not work, or this structure will not be able to render the non-structural performance level to NA level. So these are all not recommended. Similarly, in the NB also, this one are not recommended. In the lowest row, structural performance level is very high and non-structural level is not considered. So it is a awkward thing. That's why it is not recommended. Similarly, S2, S3 are not recommended. Structural performance level 4 and non-structural not considered is allowed, 4E, because 5 is allowed, so 4E can be allowed. Last one, structural performance level low non-structural not considered is not recommended. In between these two, you have 2A, 2B, 2C, 2D, 4C, 4D. These are allowable. So those will be falling something like those ranges, damage control range, limited safety range. Those will be falling in those ranges, and those buildings are allowed. So I think this table will clarify how we combine the structural performance level and non-structural performance level, and why certain combinations are not viable, not recommended. We further go into the acceptance criteria for structural performance level. Acceptance criteria are the qualitative or quantitative descriptions of the damages which corresponds to a damage state or performance level. We have said, say, life safety performance level. So what are the acceptance criteria which, when satisfied, we shall call it as life safety level? So those criteria are discussed here. S1IO, structural performance level, is a post-earthquake damage state that is safe to occupy. Because it is immediate occupancy, safe to occupy, retains pre-earthquake stiffness and strength. So no stiffness degradation and strength degradation of the system. S3 life safety is a post-earthquake damage state that is not life-threatening, we have seen earlier. S5 collapse prevention is a post-earthquake damage state where damage is almost complete but the structure stands and can carry gravity loads. That's why it is not falling down. So the basic three we have taken: immediate occupancy, life safety, collapse prevention. And the corresponding structural performance level we have seen earlier as S1, S3 and S5. And here are the acceptance criteria given in short. There are more criteria which I have not taken for the sake of brevity. So these are the basic, the main acceptance criteria. Now S2 damage control range is a post-earthquake damage state that lies between IO and LS. That we have seen earlier. And similarly S4 limited safety range is a post-earthquake damage state that lies between LS and CP. So these are the acceptance criteria for structural performance levels. Now let us see the acceptance criteria for some non-structural performance levels. These are all available in FEMA documents. FEMA means Federal Emergency Management Agency of US. They give documents for all emergency cases, fire hazard, earthquake hazard, flood hazard and so on. And they give the name of the document by this FEMA and a number. So FEMA 356 is very famous for building. We have taken those information from this document. These documents are freely downloadable in the net. So NA we have discussed. This is the first non-structural performance level, operational name. Is a post-earthquake damage state where the non-structural components support pre-earthquake functions. So functionality is not lost. It remains operational. NB means immediate occupancy performance level for non-structure. Is a post-earthquake damage state where non-structural damage occurs but services like ingress, that is going inside, egress means coming outside of the building, doors etc. are available. If these are not available, you cannot come out during the earthquake and you will be trapped inside the building. NC is life safety. Is a post-earthquake damage state where non-structural damages occur but are not life-threatening. ND hazard reduced is a post-earthquake damage state where non-structural damages occur but big elements do not fall down. NE not considered. Non-structural health is not considered in the system. Now building performance level we take further from the FEMA 356 to understand the amount of damage. So damage conditions we have taken: overall damage, general damage and non-structural damage. From the FEMA documents we have taken the outlines, not everything together. So overall damage for well building is very light, IO building is light, LS building is moderate, CP building is severe. This is the overall damage. General damage for well building: no permanent drift, that is elastic drift only, original strength and stiffness retained, services operational. For immediate occupancy building system: no permanent drift, original strength and stiffness retained substantially, minor cracking may happen. In life safety buildings, some residual strength remains, some permanent drift, gravity load is carried, some beyond economical repair. Some elements go beyond economical repair. CP building, little residual strength and stiffness will remain. Gravity load is still carried, that's why it is not collapsing. Large permanent drift will happen. Some exits blocked, infill failure, and many elements will go beyond economical repair. In fact, a CP building cannot be repaired, cannot be rehabilitated. After earthquake, it has to be dismantled. Non-structural element damage is like this. Under operational level, negligible damage, services available may be from power backup, because immediately after an earthquake the electricity will go, so you need to have power backup, and power backup there, then the damage is so less that it will be operational. For immediate occupancy, components generally secure but may not function, so here functionality may be lost but the damage is not there. In the life safety condition, many components damaged, life not threatened. Life threatening may happen due to the falling hazard, which may be the non-structural elements, and sometimes structural elements also, a part of that also may fall. It is called falling hazard. In collapse prevention state, extensive damage will take place in the non-structural elements. So this we further carry out in terms of the types of the building. So types we have taken are RC frame and steel frames and RC shear wall. In the FEMA document, the primary is given, secondary is given. We have taken primary only because that is more important. So we have taken RC frame buildings, steel frame buildings and RC shear walls, which are these three types are important and common. So immediate occupancy RC frame, minor hairline cracks may happen, strain below 0.003, drift is 1% transient. Transient means non-permanent. This strain level in Indian code is 0.0035. In life safety, extensive damage and cracks in beams, drift 2% transient, 1% permanent. Transient means elastic and permanent means inelastic drift. For collapse prevention, extensive damage and plastic hinge in beams will form. Drift 4% transient or permanent, total 4%. Steel frame buildings, minor local yielding, drift is lesser here in the IO level, 0.7% transient. But for other states, LS and CP, the drift is higher in steel buildings. It was 2% here, 1% here, 2.5% transient, 1% permanent. Plastic hinges form, local buckling may take place in the members, drift 2.5% transient and 1% permanent for life safety level. For collapse prevention level for steel building, extensive distortion of beams and columns, drift 5%, very high, transient or permanent, anything. For RC shear wall, the criteria, the acceptance criteria are more stringent. So minor hairline cracking in the immediate occupancy system, drift only 0.5% transient. For life safety shear wall, some boundary elements may get damaged, drift 1% transient and 0.5% permanent drift. For collapse prevention shear wall, major flexural and shear cracks may develop, drift 2% transient or permanent. So for shear wall, as I said, all the criteria are more stringent than beams and other members in the RC or steel frames. So this gives a matrix. Now if you want to study more on this, you go to FEMA 356. There are tables available like this for cladding, glazing, partitions, ceilings, parapets and everything and more. I have taken only one part of the table. There are more tables available. So you can go through and understand the acceptance criteria required, which are to be satisfied, so that I can call the system belonging to a particular performance level. Now in the beginning, first slide we have said PBSD means designing for desired targets, target design criteria and under specified hazard level. So unless we define the hazard level, the things will not be clear. That's why I have taken up the nomenclature for hazard levels. So earthquake having probability of accidents is given like this, 50% chance of probability in next 50 years. This is written like this. It has a mean return period 72 years. 20% chance of accidents, probability of accidents in next 50 years. It has a mean return period of 225 years. 10% chance in 50 years, 474 years return period. 5% chance of probability of accidents in 50 years. This is not given. 2% chance of accidents in 50 years, 2475 return period. These return periods are rounded up for the sake of common use. So it is taken as 75, 225, 500 and 2500 years. As you see, as the probability of accidents reduces, the return period increases. This indicates the earthquake size is becoming bigger and bigger. So this is the most severe earthquake. Return period, it comes out after, generally say after 2500 years. But that 2500 years starts today and it may come tomorrow. So you cannot wait for 2500 years for your structure to build, and you cannot say that since it will take place after 2500 years, today I may not design for this level. No, this time span starts tomorrow or today itself. Now the ATC 40 document, Applied Technology Council, and FEMA documents 273 and 356 have given names to these particular earthquake hazard levels. So the SC is the serviceability level, 50% chance in 50 years, and 10% chance in 50 years is called design earthquake, which is called in FEMA 273 and 356 basic safety earthquake 1. Basic safety earthquake 1. 5% chance in 50 years is called maximum earthquake in ATC 40. And 2% chance in 50 years, the highest earthquake, is called basic safety earthquake 2, both in the two documents. So here of importance is the design earthquake, for which is generally designed, and basic safety earthquake 1 and basic safety earthquake 2, for which we also design and check the buildings so that it should satisfy our performance levels and acceptance criteria. So design and rehabilitation objectives are written like this. Basic safety objective BSO, it indicates it should satisfy LS performance level under BSC 1, basic safety earthquake, that we have discussed in the just immediate previous slide. If the structure satisfies LS level under BSC 1 and CP performance level under BSC 2, highest earthquake, lowest performance, if these two are satisfied, we call that as the basic safety earthquake. That is, any structure desirably should satisfy these two. Very high earthquake comes, it should not collapse. So CP. Moderate earthquake of BSC 1 level, then it should show at least life safety, life should not be threatened. That's why it is called basic safety earthquake. Now if we go higher of the safety objective, then it is called enhanced safety objective, ESO. It is beyond the BSO. And limited safety objective, it is called LSO, which is lower than these two. We have taken a matrix here for the hazard level in terms of the probability of accidents. We have discussed this all. So here it is BSC 1, here it is BSC 2, and the structural building performance level have been given here. Operational level 1A, immediate occupancy level 1B, life safety level 3C, and collapse prevention level 5E. We have written the letters A to P here in the cells consecutively. So these cells, let us take this cell F. What does it indicate? It indicates the building performance level here is IO, and this building performance level has to be achieved under the probability of accidents of the earthquake 20% probability in 50 years, this level of earthquake. So similarly, all other cells are telling about the performance level of this building and the corresponding hazard level. Now our objective was the BSO, basic safety objective, to be satisfied, or you can go for enhanced safety objective or limited safety objective. So how to get out of all this? It is here like this. If you take the cell K and cell P, then what does it takes? Life safety under BSC 1 and collapse prevention under BSC 2. This we have seen just in the previous slide, and this any structure should always satisfy. At least it should stand without collapsing for the very high earthquake, and for moderate earthquake it should not threaten the life. So these two combinations of cells K and P, if we satisfy, it is called the basic safety earthquake. Similarly, other cells, if you take, enhanced safety objective will be satisfied when you take K plus P, which is basic. You have to take these two. So these two taken together, and you additionally take any of these A, E, L, H, F, J, or N. What is A? You see, I have satisfied the basic safety objective K and P cell. Now I have taken also A. A is the highest cell here, highest performance level of the structure. However, the earthquake is not very large here. Earthquake is of small level. So for the small level earthquake, I am satisfying operational level of the building. So I have enhanced it from the basic safety earthquake. That's why this is the ESO, enhanced safety objective, satisfied. Similarly, you can take other cells E, L, H, F, J, and N. Similarly, if you take only M, N, or O, then also it will be called as enhanced objective. Why it is so? Say M. What is M? It is highest performance level, highest earthquake level. So obviously it is enhanced objective. N, highest earthquake level, and immediate occupancy also good performance level of the building, so it is enhanced. O is also similarly life safety, but under highest earthquake. So if a building exhibits life safety in highest earthquake, it is also good building. That's why it is called enhanced objective. Now limited safety objectives are lower. So if you satisfy only P, K, C, or G, or H, L, it will be limited. Only K means life safety under BSC 1 level earthquake, nothing more. So that's why called limited safety objective. Thank you very much. We have come to the end of this video, part 1 and part 2. Please subscribe the channel, like and share the videos. Put your comments on the comment box with any inquiry. I'll be glad to answer the inquiries. Thank you.